Hi everyone, I welcome you to the presentation of this video on isometric projection. Okay, so engineering drawings are always drawn in orthographic projection. So for the presentation of detailed drawings, this system has been found to be far superior to all others. Okay, so essentially isometric projection is a projection we use to represent 2D objects in 3D. Now, I would actually urge those who've not watched the isometric projection, the orthographic projection, to watch that before you come to this. Okay, but even if you didn't see that one, you can still understand this one. So we use 2D presentation and then we view them in 3D. For example, you may be given this, which is the orthographic projection, which has the front view, top and side, and then we can do the 3D of this. It would look something like that. So this is the isometric projection, whereas this in 2 dimension is the orthographic projection. So there are a lot of ways in which we can draw isometric drawings, but for this video our presentation is on the box method. So to draw an object in isometric projection, you need to take the following steps. So you might be given this object, an orthographic projection, which has got it's an isometric projection which has the plan elevation, the end elevation, as well as the front elevation, like that. So as when the question comes, actually they'll give you this view, which is the end elevation, that view, as well as that, and then they would want you to produce this 3-dimensional object. So what are the procedures, or what are the steps? So step number 1, when given the plan, front and end elevations, you need to draw a box with the length, breadth and height equivalent to the given dimensions. Okay, so these, of course, the end elevation will have dimensions there. Okay, even the plan will have its own dimensions, and when you view it from the front elevation, you see those dimensions. So you draw a box whose breadth, like in this case, this distance from there to there would be a distance from there all the way up to there, where this one is ending. Then for the height, you check the height of this box, like from the bottom to the top, how high is it? So that will be your height. And then for the breadth, it's the distance from there all the way up to there, this length there, or in short the length of this side is the one which will be your breadth there. So you draw this box. Okay, upon doing that, you go to step number 2, which is saying draw the images of the elevations on the surface of the boxes. So what you're seeing, for example, if you view from the end elevation, what you're seeing there, draw it on the surface of this box. So that yellow part is that you can see there. If you view the plan view there, which is that blue part, you draw it there according to the dimensions given. And then if you check that green part there, you draw it like that. Once you do that, you go to step number 3, which is saying complete the object by connecting the lines. So start connecting the lines according to the way you see them there. So these are the connection of the lines. Okay, once that is done, then you would have made, because they would have given you the yellow, the blue and the green, and then you do the 3D, which is this one. Okay, let's now go to a practical example. So the question is saying draw full size and isometric projection of components shown below looking in the direction A. So they've given us the front elevation, which is this one. We've got the end elevation, which is this, as well as the plan. So because the plan is viewed down, this obviously is in first angle projection. So this will be your plan, that will be your view, your end elevation, and this is your front. So they want, when you make a 3D, you should view it at this angle, at this point A, and all the dimensions are in millimeters. So we start with a box, of course, following the dimensions. Okay, so we do that box where from the front elevation, this length here is this one here. Okay, then we've got height from there to there. How high is it? That's the height you have there. Then the breadth can just be gotten even from here, or this distance there. This will give us the breadth, which is this one there. So once we have our box like that, we can draw that blue part we are seeing from the end elevation. So that blue part is this part here, but you note the dimensions. Okay, so when you are to view this thing from this point, yeah, we are seeing that, but there is this part. How do we view that? That part, it's this part, putting the thickness there, should be that thick. Okay, it has a circle there, which is that one there. Okay, so when you stand from this point, you view like this, you just see as if these things are joined, as if it's one, which is that one there. Okay, and then there is this part. Okay, this is solid, but it has dotted lines for the circle, because this circle is a hole, it's a through hole there. So when you view from this side, you will not see the circle. That's why those are the dotted lines there. You see this thing there, which is this there. Okay, though in here it's looking like this. This is because when you're viewing from here, this thing which is here goes all the way there, so you just see as if it's one thing attached like that. Okay, so you're going to have that. Okay, and then when you view from your plan, which is this one, these dotted lines are representing this portion which is going all the way there. There's one there and there's another one going all the way, which you can see. So when you view from the plan, there will be two lines going all the way like that, but you can't see them. They are passing down, they are connecting to this top. Okay, and then these two dots which are there, this thing, as I said, it's going all the way, it's reaching there. And then these dotted lines you're seeing here, they are for the circle, because when you view from up there, this is a through circle. It's there, but you can't see it. So this is a 3D which will be produced. So those are the simple steps we take to draw in isometric projection. You can try the following as a task. So two views of a plane shaft bearing are shown below. Make a full size isometric drawing of the bearing. So you have this. Okay, so this is your front view, and then this is your side view. So try to follow the procedures I've given with these dimensions given. The diameter of the circle has been given to be 50 millimeters. Okay, thanks for watching.